Example 8. Example 8 says, a deposit of $50 is made on the first day of each month in a savings account that pays 6% compounded monthly. What is the balance of this annuity at the end of 2 years? Okay, so we're going to need our formula for compound interest. So remember the formula? A equals the principal, that's the amount that you put in, times 1 plus the interest rate divided by the number of compoundings per year times, or raised to the number of compoundings per year times the number of years that you're investing. So notice that this exponent right here, if you multiply the number of compoundings per year times the number of years equals, that's the total number of compoundings. So for example, if I was going to say the first month I put in $50, that $50 is going to be in there for 2 years or 24 months. So I would calculate how much it's worth at the end of that time by doing this. A equals $50 times 1 plus the interest rate is 6%, so it's 0.06. It's compounded monthly, so that is over 12, and it's being raised to the 12 times 2 power, right? So that is A equals 50 times 1 plus 0.06 over 12 to the 24, right? 24 is how many times this was compounded. Okay, but here's the thing. Here's the thing, is that this is going to happen. Every month we're going to put in another $50. So after 1 month, we put in another $50. But it's not going to be in there for 2 years, right? Because the 2 years is 2 years since the beginning. So it'll only be in there for 1 year and 11 months. So that for the second month, right, this is for the first month. For the second month, for that $50, we will have A equals 50 times 1 plus 0.06 over 12 to the 23. The total number of compoundings for it will be 23. Right? For the next $50 that goes in, it'll only be in there for 22 months, and then 21 months, and then et cetera after that. All the way until you get to that last month that you put it in, it'll only be in there for 1 month. So we're looking at a formula that looks like this, right? It's the sum, and I'll use n as the index. N equals 1 to 24 of 50 times 1 plus 0.06 over 12 to the n raised to the n. So in fact, when I put in n equals 1, that's going to be for the $50 that was just in there 1 month, right? That I put in n equals 2, that'll be in for 2 months. But I put in n equals 24, that's the first $50, this $50 that we put in. Okay, so now I can write this as n equals 1 to 24, and let me simplify. 1 plus 0.06 over 12. I'm doing this in the calculator. Is 1.005. Right. So now we know that our first month A1 is going to be what you get when you plug in n equals 1. So that'll be 50 times 1.05, which is $50.25. And we are having an issue. Is $50 right? The R is the 1.005. So if I did the sum would be A1 times 1 minus R to the N over 1 minus R. So I'm going to plug in, it'll be S24 equals equals 5025 times 1 minus 1.005 to the 24th divided by 1 minus 1.005. And that I can put in the calculator. And I did it wrong. $50.25 times 1 minus 1.005 raised to the 24th. Get out of the exponent, end parentheses, divided, start parentheses, 1 minus 1.005. And it looks like it is $1,277.96.